ผมเพื่อไม่ให้เป็นการเสียเวลาครับผมขอเริ่มช่วงสุดท้ายของรายการนี้เลยนะครับผมขออนุญาตเป็นภาษาอังกฤษนะครับผมThe last session of the APAM 2026 is the last talk in the topic supporting math teachers and introducing math grad students to them, a program by Professor Solomon Friedberg from Department of Mathematics, Morrissey College of Arts and Sciences, Boston College, USA. So for now, may I now invite Professor Yosanami Mark to introduce the speaker.
So let's hold on a little bit. I saw many people arriving. Okay, good morning. It's our pleasure to introduce. It's my pleasure to introduce the last speaker. Our last speaker is Professor Solomon Friedberg from Boston College. He is a leading researcher in Langland program, a branch of number theory, where he made a major contribution to automorphic forms, representation theory, and L function. On top of his research and his past service as the math department chair, Professor Friedberg is deeply passionate about math education. He spent a lot of time working closely with K-12 math teachers all across the United States. When he's not working with math or mentoring students, you can usually find him traveling the world, enjoying the art and outdoor activities. Today, he is here to bring his academic and educational world together. His talk is titled Supporting Math Teachers and Introducing Math Grad Students to them program. So let's give him a warm welcome, Professor Friedberg.
I could talk without a mic. I talk loud, so it would have been okay. But it's even better to talk with a mic. Good. So let me begin by thanking the organizers of APAM 2026 for the kind opportunity to speak here, and the whole math department at Chula. It's just been a wonderful week visiting, and I'm very appreciative for the chance to be here and to meet and interact with you. And I'm hoping that this lecture is the beginning of further interactions that it sets the stage for. So the plan for my talk is this. I want to just give you one slide about who I am to give you a sense for where my remarks come from. It's not that I'm important, but it gives you a context for what I'm about to say and who I am saying it. And then tell you about mathematicians in K-12 math education and make a key suggestion, which I think is a little bit out of the ordinary for the United States. And then talk in some detail about the program that I and my colleagues have put together at Boston College. And then at the end, talk about implications for other programs. Now, this is a talk in math education, and you all know that a key to math education is active learning. So your job is an active learning job. I can tell you about a program in the United States, and that has a context, a culture, a government structure, sociological structures that are part of my world. And your job is to take these ideas and ask what about them could be used in Thailand. But of course, they have to be changed for your context, for your culture. And so I think this is the work of international mathematics education. If we're going to learn from each other across countries, we can't just take the same ideas. We have to take the ideas and always change them to make them fit here, to fit your country and your people and your students. So I'm passionate about showing you ideas with the hopes that you will see within them something that's of value to you, but certainly after you change it to make it fit Thailand and to fit your country. And that's the goal for my talk. Okay, so just a little bit about me, one slide. I'm a mathematician. I work in number theory and representation theory, as Professor Yad explained. And my first published paper was in Mathematische Annalen in 1983. The gray hair is well-deserved, because that was a long time ago. And my latest published paper in mathematics is in the Journal of the European Math Society from this year. I also have a more recent paper in math education that came out just this past week. I've been involved with math education for many years, not when I got my PhD, but about 10 or so years after my PhD, I began to get involved. And I wanted to just give you a quick hint of the work I've done so you have a sense for the context of my remarks. So I've been involved with high school math teachers, in-service math teachers for many years, working with them. I'll tell you more about that. I also have been teaching classes in math content for future elementary teachers. And of course, when you teach math content, you have to mix it with pedagogy for it to be effective. So I have worked with future elementary teachers at my university also for many years. I've designed programs to help math graduate students learn how to teach mathematics. Getting a PhD in math doesn't mean you're automatically successful at communicating math to your own students. And I've worked with mathematics graduate students about their teaching also for many years. In the United States, each state has its own set of rules for what math is taught when. They're called standards. And I have led a nationwide project to look at the math standards of the different states of the United States and to evaluate them. That had other people on it, but I was the lead, and we have a report that came out some years ago about the math standards of each state in the United States. I've also written articles for newspapers about math education, supporting learning and teaching deep mathematics, trying to support teachers, and trying to support policy decisions that I believe will be helpful for mathematics. We as mathematicians have to stand up for math content. And part of that means talking to people who are outside of mathematics altogether. I have an article in USA Today, and it was shared on Facebook something like 30,000 times. If you take all my years of mathematics, I'm sure I never had 30,000 people look at all my math papers. But my article in USA Today was shared over 30,000 times. I was chair of the United States National Commission on Mathematics Instruction of the US National Academy of Sciences, trying to do policy work at a national level. And I am a member of the International Program Committee for the International Congress on Math Education 16, which will take place in Prague in 2028. There's also a distinguished colleague from Thailand on that committee. So when I talk about the work of international math education, it's work that I really live and believe in. And so I hope to share with you the idea that it might be exciting to learn from people around the world and to get ideas from them, which you then have to take here and work on implementing for your country. So I'm deeply interested in supporting mathematicians, especially mathematicians involved in math education around the world. And so that's the context for these remarks. The mathematicians work, as you'll see in my project, work together with math educators. So if your identity is primarily a math educator, I certainly mean that this work is to be in conversation and with full respect and support for math educators. Okay, now here's the context that I come to this work from. Mathematicians have actually been involved in math education for many years. The first president of the International Commission on Mathematics Instruction famously was Felix Klein. So this is not a new idea that mathematicians should contribute to K-12 math education. And here are some roles for math education, particularly in the United States. You can see again if they resonate with the situation in Thailand or if it's not exactly the same. Well, we teach pre-service teachers. By that, I mean we teach university students who then become math teachers. And we are responsible for teaching them content that they will then be able to use and implement and include in their own work with students. We often also work with in-service teachers. I will tell you about a program for in-service teachers. Math circles are a famous example also of work with in-service teachers. Just because someone leaves the university doesn't mean that they're done learning mathematics, and doesn't mean that they won't get enjoyment and benefit from continuing to learn and be engaged with the mathematics, and math professors can play a role in that work. Mathematicians contribute to math education policy. For example, there are people that say, oh yeah, data science is so important. Let's stop teaching geometry. That's old. It's been around since Euclid, and let's teach data science. We need mathematicians to say, no, you've got to learn your geometry. You want your architects to build buildings. You want to plan cities. You want to understand spatial relationships. And if you want to add data science, we have to not take away other important mathematics. So math education policy is a very open-ended world, and the opinions of mathematicians are very valuable and important in helping the government formulate math policy in a good way. I consider myself an advocate for math education. I want to support teachers. In my country, teachers often don't have the respect that they deserve, and I can help support them and help them get the respect and talk about the hard and valuable work of teaching. That's a role for mathematicians. Now, these categories are not disjoint. Mathematicians always talk about whether categories are disjoint or not, so you can hear me speaking in our language. So for example, requirements for future elementary teachers to take math courses at the university is a question of policy. And in my university, the education department maybe says, look, our students are already way past elementary school. Why do we need to give them more math courses if they're going to be elementary teachers? And we have to explain to them why knowing really elementary mathematics deeply and understanding different ways of scaffolding ideas is very valuable, and that's worth university students' time. So that's a combination of those categories. And one more example, the topics in what is taught in K through 12, as I was mentioning, are often specified by government. And so we have to be involved to really have a voice in those decisions. Now, some mathematicians do research on K-12 math learning. Some develop K-12 math curriculum. Some run amazing websites. I respect all that work deeply. And so there's lots of ways that mathematicians are involved. I'm talking about ways particularly that I am involved as someone who focuses on research, but who wants to contribute in a serious way to math education. And I think if you're going to do research on K-12 math learning, that becomes your primary focus. And I value that work. It's different from my own work, but I certainly value it. Now, my argument, and maybe a key takeaway, is that all this work is about K-12. But K-12 math education benefits from and needs the involvements and perspectives of mathematicians. If we're going to decide what math to teach, it's important that mathematicians have a voice in the way students arrive at the university and what their preparation is. And we need to be involved to help that. We can be the advocates for deep math understanding, coherent math reasoning, not just getting the answers by an algorithm, but actually understanding. We need to be advocates for math understanding, and we play an incredibly important role in K-12 math education. But there's a bigger need for mathematicians to be involved than there are mathematicians who've really thought about K-12 math education, can talk coherently and with understanding about it. And so I think the need for mathematicians to step into the role of connection to middle school, high school, elementary school is greater than the supply of people who are able to, who are mathematicians. For example, in my country, education is very local. There are over 18,000 different public school districts. And you can go 10 kilometers from my house and be in a completely different district with different textbooks, different choices of curriculum, teachers that are hired by a different system, different pay scales. Everything is very local in the United States. So with 18,000 districts, it's completely impossible that there's one mathematician to work with each district. There aren't that many mathematicians who've thought about K-12 math education. So there's a gap, especially in my country, and I don't know here, but in my country, there is a big gap between the supply of mathematicians who really can contribute to pre-collegiate math education and the need for them, the value they will add by being part of the system. Now, this learning to be involved in K-12 math education is a process. It's not something that happens automatically. After all, there's knowledge about K-12 math education that's different from what we teach in a PhD program. It's different than the knowledge you need to write a research paper. And I would like to use the phrase a learning curve. A learning curve is something that it's a path that you walk on. It's the path to learning about the issues in the education system, the challenges that teachers face, the places where things are working well and the places where improvement is needed. So there's a learning curve that's necessary for a mathematician who wants to be involved. And to talk about K-12 math education, one has to talk about both content and pedagogy. One has to talk about active learning. One has to talk about productive struggle. One has to talk about methods of pedagogy, differentiated instruction. In my country, working with English language learners whose knowledge of English may be an impediment to them learning math, but who can certainly learn math in whatever language they come to my country from. All of those are things that are part of the discussion, and to not have thought about them would be a weakness. So one has to be able to discuss them with math teachers because they are part of the life of math teachers. So learning to talk about them, to be articulate, to speak coherently about the need for deep understanding of mathematics, to go beyond getting the answer to deep understanding. That's what we can add as mathematicians with our specific training as mathematicians and with our perspective. But it takes a little practice to talk about this stuff. Certainly a PhD who's very focused on their research doesn't necessarily have that skill set in their pocket. They have to develop it if they're going to be effective. And also, mathematicians need to learn to listen. So in math, we often talk. We give lectures. We know we're right. We prove the theorem. And so it's sort of something that's not automatic for mathematicians to listen. And we have to listen to diverse points of view and discuss them. There are people talking about math education who are experts in child development. I'm not an expert in child development, so I need to listen to them. I need to learn from them. Our perspective is valuable and it's deeply important, but it's not the only perspective. So the attribute of listening is something that maybe, one needs to develop. It's not automatic. It also, of course, depends on personality, but it's not automatic for every mathematician to really step back and listen to different points of view from specialists with different training. And I think these are all important parts of being effective in math education with teachers and with the school system. So for many mathematicians, including me, this process didn't begin when I got my PhD. I was a good teacher. People liked me. My students gave me good evaluations. But it really happened for me when my kids were little. I saw some of the issues in the school system. And in fact, I just couldn't stand there. I had to get involved because I saw some problems. And I'm not the kind that wants to complain. I'm the kind that wants to make changes and help support improvements. So that's a very common pathway in the United States. That is when mathematicians have their children and they enter the schools, that they suddenly discover the need to get involved. Now, The real point of my talk is that we can change that pathway. My proposal is that involvement of serious math graduate students, serious mathematicians doing work in mathematics can begin as early as graduate school. So I'm going to tell you about a program that does that, that involves math graduate students getting a PhD in mathematics and starts to get them thinking about teachers and the work of K-12 math education. And I'm going to tell you about not just the program, but about the consequences for those graduate students. And I think you'll see the consequences are very striking. So, but the first desiderata, the first insistent point is that this involvement has to be in a measured way. It's not supposed to distract graduate students from getting a PhD. That's not the idea. The idea is to complement that work and not get in the way of it. And it's certainly not assumed that the graduate students will then go into K-12 math education. It's really meant to show them some complicated problems and an area of involvement, and to invite them, if they're interested, to get more involved. For example, later on in their career, when they teach service courses, they might choose to teach courses for future teachers instead of courses in calculus for their service teaching. So it's meant to prepare them to get involved as math professionals later on. And an important point, and I'll emphasize this throughout the rest of my talk, is that the teachers, the graduate students need to be supported in learning about this through interactions with knowledgeable mathematicians, more senior mathematicians who are themselves involved in math education. And in our program, we have a real gift. We have a great relation between mathematicians and math educators, and our graduate students also get to interact with math educators in our School of Education, and I think that adds additional value to our program. Now, a word of caution, and graduate students are trying to develop expertise, and they're used to thinking of mathematics as of course, properly thinking of mathematics as the most important subject in the world. I hope we all agree about that, right? Okay, so it's a little bit of a challenge for them to enter a world in which they are not the only experts. So here are some issues that arise, and in the United States, these issues have become very large. There's the famous math wars between mathematicians and math educators. These issues are very real, and they have become an obstacle to involvement that we might as well know about from the beginning. So again, there are specialists in education and in math education who already work on topics around math education. They already work on topics about K-12 math teaching and student learning. And some of these specialists, as I mentioned, are grounded in other disciplines, such as learning theory and child development. They're already there, they're already doing work. And in fact, they sometimes have very different perspectives and very different foci than mathematicians. We might be very concerned, for example, about helping students from all groups have a pathway to really achieving, to being excellent in math. Like the 10-year-old student who attended my lecture 2 days ago. So I know that's happening in Thailand. Very impressive. But you know, other math educators in the US are concerned with equity and are concerned that if some students have the opportunity to go too fast, it will block other students. So they may have different perspectives and different foci than mathematicians. And in fact, they don't always see the input of mathematicians as helpful. The math wars really were a trauma. And so I've talked to math educators who, after eating dinner with me, said, wow, you're different. We can actually talk to you. I thought I hated all mathematicians. So, I mean, I'm not such a good guy, but I'm willing to listen. And I think that there really is some work that we need to do to be engaged with specialists in other areas and have our perspectives be listened to. And we can't do it by force. We have to do it by persuasion and speaking what's important in a way that convinces others. But the point of my talk is that with our support, graduate students in mathematics can understand all of this. They're not afraid. They're capable of talking to people from different backgrounds, and they can understand the ways that they can be involved as mathematicians. As they are becoming mathematicians, they can recognize their own expertise as being valuable in this arena. Okay, so I want to tell you about our program. Again, some of this may be specific, and my invitation is to not to worry about the details, but to ask if something like that would fit you. Our program is a 6-year program based at Boston College, and we work with high school math teachers in what are called high-need districts. High need is a government designation, and it indicates students who are from lower socioeconomic levels. Many of them get free lunch at school because they can't afford lunch. There are many languages spoken at home. The Boston Public Schools have over 70 languages, 70 languages spoken at home. Our program is for a small number of teachers, 14 teachers. They're already experienced. They already had a master's before they started with us. They make a 5-year commitment. They're from the Boston area, but they're not even in the same district. They're in 4 or 5 different school districts, different curricula, different structures. And they make a 5-year commitment, which is very serious. If they stop in the middle, they have to pay back a bunch of money. So it's a real commitment. And our goal is not just to make them great teachers, but to help them become leaders. And to do that, we talk about content, we talk about equity, meaning making sure that all students in the classroom are able to succeed in mathematics, and that none are left behind for, say, socioeconomic reasons. And we talk about leadership. Our program is led by faculty in teacher education and in mathematics. Those are in different colleges in Boston College. We're in the College of Arts and Sciences in math. The teacher educator is in the College of Education and Human Development. So we work together. We have a wonderful relationship and work together. We have financial support from a National Science Foundation. The teachers get a stipend, and there are some matching funds provided by my university because it considers the work to be important. And it builds on experiences from a successful 7-year project that came before, and we could see the effect of our project. We had people step into leadership roles after our project in ways that were striking. Now, the new ingredient in this project, and it's something I've already mentioned, is the involvement of math graduate students. So I want to tell you about the program and very quickly, a bunch of bullet points about it, and then tell you about the outcomes for teachers and the outcomes for math grad students. Okay, so the work with the teachers. Monthly meetings. We wish we could get them more than once a month, but they're very busy people. 2 and 2.5 hour meetings at night with thought-provoking math problems, teacher-led activities, and some dinner as well. Always give people food, helps them come. All right. Monthly meetings, some of them also include discussions on teaching practices related to engaging students in mathematics, having energetic and thinking alive classrooms. There's also a colloquium series. We invite outside speakers from around the United States, in fact, around the world. And we're open to all points of view. We're capable of hearing things we disagree with. We're not afraid of that. We can talk about it and think about it ourselves. So we don't have any one point of view, and we're really, truly open. We do mentorship in 2 ways. First of all, we mentor the teachers. And the mentoring is of 2 forms. There are both mathematicians that go to the classroom and watch the math lesson, people like me watching teachers teach. And we also have even more expert teachers watching the teachers. And that's something that happens in the early years for a special reason, that we want our own teachers to then mentor other teachers. And as I'll explain, we've found that learning to mentor is itself a process that is not free and easy. You can be a really good teacher and not know how to teach others, not know how to support and mentor other, say, new teachers. There's also coursework in math or education at Boston College. And then there is a 3-day summer retreat, which tends to have a focus on a topic such as strategies for promoting the success of minority students in the classroom, or a focus on leadership. And lastly, each teacher is asked to do a capstone project, do a project their last year that will make a difference to their entire school or district, and then to report on that project to us. And sometimes they have given reports even before it's finished, and they've asked for advice about how to finish it. Okay, now the math grad students are involved as follows. So let me tell you a bit about math grad students. So first of all, they're selected by the math faculty, such as me, involved in the project. And we only have 3 at one time because we don't want there to be more math grad students than teachers. We want to focus on the teachers. We have a small number of math grad students. The grad students have to be making good progress on their own studies. They have to be successful in their own work with students, and they need the approval of their PhD advisor. This is meant to complement their work in studying math, not to take the place of it. The students begin with an orientation meeting from me, which tells them about the program. We're not expecting they've ever thought about high school teaching. They were students, but they never thought about this. So we start with an orientation program. And then they attend the monthly meetings with the teachers and the colloquium lectures. And our grad students are often programmed to be TAs. They're programmed to answer student questions. And we say, please don't answer the questions for the teachers. We want active learning. We want teachers to find the answers. So we invite you to listen and in the process of listening to ask questions about what you see and hear. The teachers often talk in acronyms, IEPs, individual education plans, and many other acronyms. So the teachers sometimes ask us, what did all those letters mean? We want them to take notes on what they saw and then do an analysis. And the analysis takes place at a separate meeting after the teachers' meeting. On a separate night, we do it by Zoom at night, and we call it a debrief meeting. It's a chance for the graduate students to talk to the two of the math faculty, I'm one of them, about what they saw, to ask their questions, to talk about what issues they see, what surprised them about the way the teachers acted, and what did teachers say and what did teachers not say. And that process of interacting with the teachers and then talking about it is tremendously valuable and helps them understand the system of K-12 math education and teachers to a great degree. And the students are paid a small amount of money, a tiny amount of money, and they're invited for 1 year, but some have stayed for even more. Okay, now the outcomes reported by teachers. One of them is deep math content knowledge. The teachers learn math more deeply. They learn new ideas for teaching from other teachers. They get things they can use in a day-to-day way. They have increased capacity, and they're thinking a lot about how to not leave students behind, to make sure all students, including students, say, from minority backgrounds, English language learners, are deeply involved in learning math. They find that they strengthen their commitment to work with these students in these difficult school districts. They find themselves, their commitment becomes enhanced through their work with us. And moreover, they develop capacities as leaders. They are used to developing relationships with other math teachers. It leads to leadership. In our last project, we had many teachers become department chairs, become assistant principals right after our project. It led to leadership. Their own mentoring skills get developed. They learn that this mentoring is a tough thing, and they learn eventually how to do it. And so they become better able to support new teachers. And There's a comment from an evaluator that we build a professional learning community. So this isn't automatic. These teachers are in different districts, but they see a tremendous amount of value in interacting with each other and in this community of mathematicians, math educators, fellow teachers. The learning community is very valuable for them. Now, what about the math grad students? First of all, they learn a lot about K-12 math education, which they may not have thought about. They have an increased understanding of teaching practices and how much it matters what you teach, how you teach, not just what you teach, but how you teach. They have a much higher understanding of the impact of teaching practices and their impact on student learning. They have an increased appreciation for teachers and the challenges that teachers face. They have a lot more knowledge about what we call vertical integration, what it means to go from high school to college, what challenges new college students are facing, what the environment they were in high school was, and how it's different from college. And that helps them become better teachers because they've thought a lot more about the step from high school to college. And in particular, our teachers, our graduate students thought a lot about how to make their own classes more equitable and more active learning focused. They took ideas from the high school teaching into their own classes. So this was a bit of a surprise to us, frankly. We weren't expecting that. But the grad students saw that what they were learning was something that they could use at the university. And it really wasn't what we were expecting them to see. But they got very excited because they were learning things that they could use to become better university teachers in the long run. Our project increased visibility in the math department. Our grad students learned about this whole world, which probably none of them had thought about before. Okay, now, some quick consequences for other programs. That whatever we did, teachers in general benefit from rich content experiences. And in our country, when teachers have professional development, PD is the acronym in the United States, when they have professional development, it's in their high school. They're sitting next to the English teacher and the history teacher. It's not about math. It may be about some general idea about teaching, but it's not specific to math. This is their chance to keep doing math, to keep learning math, to keep engaging with math. And they do not have it unless mathematicians at the university create it, because it is not in the school systems in the United States. Math education faculty and math faculty, I think we consider ourselves an example of how the two groups can interact positively and support each other, and we deeply respect each other, and we hope that that's something that we'll see around the world. We found that in our program with teachers, we have to balance math experiences, math pedagogy. And teachers love to talk about what they're doing in the moment. They love to talk about pedagogy. So sometimes you have to move them a little bit from the pedagogy and pick it up to a higher level, to the math content. And actually, our math educator is wonderful at saying, okay, let's stop talking about math teaching, which is her area, and let's start talking about the higher level stuff. You do need to do that. And again, the skill of mentoring, we didn't expect that. We assumed great teachers would be great mentors, and we learned, it wasn't obvious to us, that mentoring is a skill in its own right that must be systematically developed. So if you want your experienced teachers to be successful mentors, you have to support them in that. It's not obvious. Okay, well, just to continue the summary for teachers, that the SUSTAIN program, this 5-year program, is a great platform for developing leadership. And we watched the teachers grow over 5 years. The fact that it was so long was very important. They got to make connections, eventually become comfortable with each other. And so having a sustained program, we think, was very valuable for creating future leaders, teachers who would be leaders. And once again, the idea of being a community of math professionals. In our first project, the teachers have kept up the community even after the project ended. And we think there's a great deal of value in community. Now, let me tell you also about early stage mathematicians, about graduate students. We deduced from this, we did not know if involving graduate students would work. We had no idea if this would work. And the good news is it worked. Okay, so graduate students turned out, first of all, they were interested. They're getting a PhD in math. We also involved students who came to the US for grad school from other countries. It was a chance for them to learn about the country they were in and what students were like and why they were teaching the students they were teaching and why the students had the background they did. So it was a good thing. The students were interested. The graduate students learned a lot. They learned so much about K-12 math education from our program. And again, much to our surprise, they found the program helpful in their own teaching. We didn't expect that, but it was a shock and it was deeply true. They learned about their own teaching from our program. And we do think that the choices we made to keep involvement small and to make it for advanced graduate students who were past their exams were very good choices. We made them, and we think that they were the right choices. And we also found that the grad students need to be prepared in advance. Otherwise, they would be too likely to be TAs. So we had to talk with them a lot about what it meant to enter the world of teachers. We had to prepare them. We didn't expect that, so we learned we had to do it. And then these debrief sessions, these discussion sessions with mathematicians who've already thought about math education were very, very valuable for us. And then, much to our amazement, we didn't expect this at all. We had postdocs at Boston College say, I heard about this program, can I get involved too? And we didn't expect it, but we had 2 postdocs get involved. And we found that the postdocs loved it, and they also benefited from this. Totally unexpected. But that's why I said early stage, not just graduate students, but also postdocs. Really a surprise. Okay, so just to end, I believe that we need more mathematicians to be involved in K-12 math education. There is a need in our country, in my country, and perhaps in your country as well. I see people nodding their head, and I appreciate that maybe this is also something that applies here in Thailand. We can promote this by systematically including early stage students, graduate students, and postdocs. We don't have to wait for them to have children to get involved and the children to enter schools. We can start much earlier. And in order to do this effectively, we have to design pathways for the graduate students to interact with teachers and then not only to interact with teachers, but to observe and then question and discuss what they see with knowledgeable mathematicians who are already involved in education. So see teachers and then talk and discuss with mathematicians. And then my very last slide, with AI developing, as we all know, we're facing a new world. And we know that productive struggle is so important. The moment when you're confused and you learn, that's key in mathematics. That's key to learning. How can we have our students have productive struggle when AI can solve problems? This is a challenge that each of us in this room faces with our students. And then we also can ask, how can we use AI to make the work of teachers more productive? How can we help teachers? They have a hard job. How can we help them be more effective with a whole range of students in their classes? So this is an open topic, and it's one we're all exploring. You and me and everyone else who teaches all around the world, we're all exploring this together, and AI is itself changing. So this is a new topic that we're all exploring and learning about together. So I'd be love to talk about AI and hear about your experiences now, 6 months from now by Zoom, a year from now. I think this is a changing world, and we're all going to learn together. And wherever we are now, in a year, we'll be in a different place. And I'd also love to talk about the program that I just described to you. Again, not expecting you to copy it, but to take the ideas, modify them for your country, your institution, your teachers, your students, your context. And if I can help support you in that work, I would be delighted. I'd be delighted to talk to you now. I'm on Zoom early in the morning, late at night. even though I'm halfway around the world after next week. It doesn't matter. I would love to interact with you and support you here in Thailand in any way that I can. I've had such a wonderful visit, and it's so great to get to meet people. I look forward to talking to you this afternoon when I'm in my office, but please don't hesitate to reach out by email, and then we can make a Zoom. I'm interested in supporting you in the important work that you are doing. So thank you to the organizers for the opportunity to speak, and to all of you for your involvement in this exciting conference. Thank you.
Thank you. So, any quick question from the
Okay, it's a very nice talk, and let me introduce myself. I'm also a professor in the math department here at Chulalongkorn University, and I would like to ask you about the curriculum in your country, whether you have like different tracks for students who plan to use mathematics in different concentration in their future career. For example, some students may not be good at mathematics and they need a little bit of mathematics, while some students will go into engineering or in science and they need more mathematics. So in the US, do you have like different tracks, different programs for students? Because when they teach international program, some students they study mathematics up to only grade 10, and they did not study in the grade 11 or 12 unless they choose to take like calculus at the secondary level. Okay.
Thank you for the interesting question. The answer is of course that it's complicated. What I mean by that is that in the United States, there's not just one answer. Each state is different. And then even each state, there's not one answer. Each district is different. And then even within each district, not surprisingly, there are different pathways and students. The ones that are going to college, we hope they will take 4 years of mathematics in high school, which is 9, 10, and 11, 12th grade. High school would be by definition 9 through 12 in the United States right now. That's the way most high schools are configured. Back in my day, it was 10, 11, 12, then they changed it to 9 through 12. So we are hoping that students will take mathematics each year before they enter the university. Does that fit all students? Certainly not. And there also are students that are maybe not so motivated, that really say, I don't want to do this. We've had some interesting experiences with students that are not so interested in mathematics, but they get interested in things like mechanical engineering, and they like to build things. They like to work with their hands, and then they discover they need to learn math for that. So there are different ways of motivating different students. And I would say that most university students, I think, are supposed to take 4 years of math, but certainly not all do, and that's not the only pathway into a university. There's an enormous range of what a university means in the United States. There's an enormous range of expectations, and maybe most critically, there are students that arrive at the university and they've taken all the math, but they haven't retained any of it. So we have students who arrive at the university but are not so good at fractions. It was shocking to me when I taught future elementary teachers, but we have future elementary teachers who are going to teach fractions to kids, but they don't know fractions. We have to work on that. It's not something I expected I would be doing when I got my PhD, but it's incredibly important. They're going to be the future teachers of elementary school students. So there's quite a range about what students take and also about what students retain. All this stuff about active learning and math that they deeply understand and can use, well, that's of course an ideal. And I think, as you know, not all students reach that ideal. And so part of a challenge of a university is to take students with a wide range of student backgrounds and figure out how to help them succeed in whatever math they need for their career options. Did I answer your question?
Yes, thank you. Because recently there's a complaint that in Thailand we designed the program for secondary students based on the future use in science. Like, are we going to produce students to go into science and engineering? Well, because some students may not go in that direction. So we designed a program for a minor group of students instead of like developing program for students in varying degrees of concentration.
So I love your question. First of all, it's a policy question, and this is exactly where we need mathematicians to be involved in math policy to express our perspectives. I mean, you certainly know your perspective of your country infinitely more than I do, and this is exactly the kind of work that we need to do as mathematicians. In the US, I see a bunch of people saying we can do less calculus and more data science, but the two biggest majors in my university are economics and finance. And if you can't do calculus, you can't do economics at my university, and you can't do finance. So good luck with data science. If you didn't retain the algebra skills you'll need to do calculus, you're not going to be successful in those majors. Students don't all know what they're doing at 15 or 16. So I always advocate that we should make sure that there are many pathways open to students when they graduate from high school. And that part of the goal of high school should be to give students as many options as possible, because people change their mind. They don't always know what they're going to do with their whole life when they're 16 years old. But I think this is a math policy question, and I love it because it's a great example of where mathematicians need to stand for what you believe is the right approach to teaching math and what you think is best for your country.
Okay, I think so. We may have to stop this session because we are behind a little bit on time, and I think it's very honor to hear from the world-class educator. So please give him a hand again. Okay, so stay.